Hi, this is a video response to a series of videos about ethics that Nicotine 2 has been doing. I wanted to make this sort of a companion series, or maybe a parallel series, branching off from what Nick did with a few ideas that are a little closer to the things I'm experiencing. Now, for me, by training, I'm a mathematician, and even though I haven't been in the mathematics business for a few years, I still really do a lot of my thinking using the old mathematical techniques. And I wanted to see if I could bring a little bit of the flavor of those techniques to skepticism and philosophy and a few of the other things that are talked about here on YouTube. Now, first of all, we all have a decent understanding of what science is. We know that there are things that science discovers, and we know also that there's the scientific method itself. We know that process different from the results of that process. Now, math, people aren't so used to the difference between the two. It just doesn't come up in real life that often. Assumptions. The whole idea behind the mathematical process is to get rid of inference as much as you can. Get rid of experimentation as a verification method. What you want instead is you want everything to be absolutely derived. So you have established facts, you use logic, you get new results. It tries to throw out any sort of inference there is. Now, we know that we can't get rid of all inference. So what we do is we start with a set of undefined terms and axioms, things that we assume. Things like the idea of the number one, the idea of numbers at all, the fact that you can count something and have that be meaningful, the concept of existence, the concept of not, all sorts of things get put into this. To those base assumptions, the only thing we add is logic. The old, this implies this sort of thing. Now, in math, one of the things that we do every so often is we bump up against something that looks kind of cool that we want to study, something either that's new that we're discovering or something that some scientist has knocked on our door and said, hey, I got this thing that I've discovered that looks weird, and I don't have anything that I can mathematically model on it, or I don't have anything any sort of math I can use for a model for what I'm doing here. Can you come up with something? Oh, that gives me an idea, and it goes from there. Anyway, math is very much the idea of conclude a few things, make a new definition, conclude more things, and so on, built up from there. Now to get back to what Nick was talking about, when I first watched through Nick's videos, I was remembering back being in college, and back at that time I would have said everything that Nick is doing is just so much mental masturbation. What is the point? It's pretty obvious that you have the mathematical approach of being logical, and you have the scientific approach of inference, and there really isn't too much more. What more is there? Why is there any point to listing out all these millions of terms and giving definitions to them and studying them all? I feel differently now. Why? Well, first of all, when you go and you study out everything like Nick is doing, for one thing, you're sure you're being exhaustive. You're sure you're covering every basis. You're not just hitting a few of these and determining whether among these few of these, this one's good, this one's bad, and leaving it at that. You're also getting some sort of understanding for all the other possible ways of looking at things that are involved. And you understand what their strengths are and what their weaknesses are, and you're in a better position to be able to understand what your own thinking is like, and when somebody is different from you, what their thinking is like. And beyond that, though, there was one thing that Nick talked about that really got me, which was the importance of definitions. And he didn't say it directly, but when he talked about the word materialism and how frustrated he gets because people think of materialism, when Nick talks of materialism as the philosophical / metaphysical topic, a lot of people instead hear the materialism as in the gimme, 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 go out 1980s material girl, all sorts of nonsense that went on back then. And what this got me thinking about was the importance of being very careful in how you make your definitions in mathematics, because we can run into the same sort of problems in definitions when we're talking science or philosophy or ethics or values, anything else. Sometimes when you give a definition to things, unexpected things will pop up out of it. In math, these things are a real delight to mathematicians. We're kind of perverse that way, finding out these little strange things that your supposedly careful definition actually include. Let me give you a good example. Sets. We've all had sets. We've all seen sets somewhere in our math class while we were growing up. What are sets? Sets are really just kind of things that contain other things. That's really the whole idea behind a set. You can say what a set is by saying, all right, here's my set. My set is the set of, and then you can list out the conditions for things to go into the set. Like you can say, all right, this is going to be the set of all even numbers. Okay, we understand stuff like that. The problem was coming up with these recipes. There were certain things that we found were a little bit funny as mathematicians. Now, back about 100 years ago, when George Cantor was really codifying all of set theory, everything was looking really good. He was making up all his little axioms for set theory, what a set was, what it meant for one thing to contain another, subsets, all these other things that he defined. And everything was going great until he got a message from Bertrand Russell. And Russell said to Cantor, I think everything you're doing is magnificent, except there's a little problem. And he explained what came to be known as Russell's paradox. Because sets can be a little bit hard to understand, let me put it in maybe easier to grasp terms. Think of a book as being my set. And when I say something is going to belong to the book, that means the book refers to it somewhere. That's all. So if I have a book that only refers to even numbers and that's all, okay, well, this book is like the set of all even numbers. Okay, fine. What happens if you take a look at the book? First of all, look at this book. This book, I'm going to say that my definition for this book is that it's going to be the list of all books that list themselves, that refer to themselves somewhere. The question is, does this book refer to itself? Well, if it does refer to itself, then it should be in the book. That means it would refer to itself. That's kind of circular, but it makes sense. The problem is it also makes sense if the book doesn't refer to itself. If the book doesn't refer to itself, then it shouldn't refer to itself, because this is the book of books that refer to themselves. Or, yeah, books that refer to themselves. This is a little bit weird because you can't really determine, you get this one thing that's indeterminate with whether it belongs in or out. We weren't really careful. But that could be easily glossed over. What really became interesting is what happens if you reverse the idea. What if you have a book that lists all the books that don't refer to themselves? The question is, does this book refer to itself? Now, if the book does refer to itself, that means, wait a minute, the definition of this book was this book only has things that don't refer to themselves in it. So the book wouldn't refer to itself. So, okay, that means if it does refer to itself, then it doesn't refer to itself, and that's just bullshit. It can't do that. So, what about the other way around? What if it doesn't refer to itself? Well, if it doesn't refer to the self, the rule for belonging in the book says, well, anything that doesn't refer to itself belongs in the book. Oh shit, we're screwed. So either way we look at it, whether we start by assuming it does belong to itself, or whether it doesn't belong to itself, we're run into a problem, and that was what Russell's paradox was. Now, in the long run, mathematicians, we fixed it. I'm not going to go into how or anything like that. It's way too messy, but it's just really interesting. The whole point of this whole talk was to say that all this nitpicking over little tiny definitions is important. Hope to see more videos out of you, Nick. Until then, everybody, see you later.